Before Newton, we could describe the motion of the planets. We had Kepler's 3 laws of motion, and they could describe what the planets did very, very accurately. But we couldn't explain why. Why did planets go around the sun? Why did the moon go around the earth? So, you've watched the animation of the cannonball, and here are a few questions to think about. Why does the cannonball travel further when it's going faster? What force is constantly pulling it towards the earth? Otherwise it wouldn't fall towards the earth. And then what keeps the cannonball in orbit around the earth? Okay, so in each case I've added an arrow to show the force pulling the cannonball down towards the earth. And of course the force that does that is gravity. Gravity pulls the cannonball down towards the earth, or rather gravity pulls the cannonball towards the center of the earth. On the last diagram, the bottom right diagram, we can see there that the force of gravity towards the center of the earth, and if that force of gravity wasn't there, the cannonball wouldn't go round in a circle. It would just go off at a tangent. So the pull of gravity keeps things in orbit. And that was the brilliant idea of Isaac Newton. Isaac Newton figured out why the moon orbits the earth. What keeps the moon in orbit around the earth? And the answer is that it's the same force that pulls an apple to the ground when it falls off a tree. In other words, that force is gravity. Gravity keeps things in orbit. If you thought the animation was a clever idea, I agree. It wasn't my idea, it was Newton's. This is a picture drawn by Isaac Newton to explain why things stay in orbit. The force of gravity provides the centripetal force necessary to keep a smaller object in orbit around a larger object. Centripetal means towards the center, as in the case of the Earth, a satellite stays in orbit around the Earth because the force is towards the center of the Earth. In the case of a planet going around the sun, the force is towards the center of the solar system. If we notice these 2 planets in orbit around the sun, it's gravity which keeps them in a stable elliptical orbit around the sun. Notice that the blue planet on the inside is traveling faster. Now, why would that be traveling faster? Okay, so, well, what is gravity? All masses attract each other. The elephant and the bananas and the cup of coffee and the telephone, they all attract each other. All masses attract each other. But gravity, compared to a few other forces, if you do A-level physics, you'll find out, is a very, very weak force. And we don't notice this attraction between objects. I mean, obviously, sexy women are attracted to me for some reason, but that's another thing. Okay, all objects attract all other objects, and that's what gravity is. Okay, the force depends on the mass of both objects and how far apart they are, which is why we only actually notice gravitational forces if at least one of the objects has a very, very big mass. For example, the sun, or if it's a planet. Okay, unless one of the objects has a very large mass, then it's very difficult to even measure gravitational forces. Newton's universal law of gravitation, now it does get a little bit mathematical here, and in the specification it says that you do need to know that the force is proportional to the product of the 2 masses. So if the masses are m1 and m2, then the force is proportional to m1 times m2, and that it's inversely proportional to the square of their separation. So if the two masses are separated by a distance r, then the force gets smaller as r squared gets bigger. And that basically means that gravitational forces get weaker very, very quickly as r gets bigger. As masses get further apart, the force gets weaker and weaker very, very quickly. If you're reasonable at maths, you'll actually understand that writing it down as an equation, F is proportional to m1 times m2 over r squared, is actually a much easier way of representing it and understanding it. Okay, so the outer planet travels slower because the gravitational force due to the sun acting on it is less because it's further away. Because it's further away, the gravitational force is much weaker, so it travels much slower. So finally, Newton's model of gravity could explain all of Kepler's laws. If you do the maths, all the mathematical bits, t squared over r cubed equals a constant, etc., mathematically, Newton's laws of gravity can explain all of Kepler's laws. So now we know why planets stay in orbit around the sun. It's not angels pushing the celestial spheres around and rubbish like that. It's basically thanks to gravity. Gravity keeps things in orbit.